Warahmatullahi wabarakatuh, and hello everyone. Okay, so today we will continue our lecture into chapter 5, which is fluid statics. Okay, in fluid statics we will learn about the density, pressure, and then we will go into the Pascal principle, and then Archimedes principles, and buoyancy. Alright, so first, I will explain about the fluids, which is about the density, pressure, and pressure in fluid. Alright, so we all know that the density is mass per unit volume. So we can calculate the density of an object by using the equation of mass divided by the volume. Alright, so the density we can the unit for density is kg over meter cube. Okay, why kg over meter cube? Because mass is kilogram and V is volume, which is the unit for volume is meter cube. Alright, so for example, what is the mass of a solid iron wrecking ball of radius 80 cm? Okay, so they are given the radius of the iron ball, which is radius is 18 centimeter or 1.18 meter. Okay, so they ask the mass of a solid iron, and they are given the density. Okay, so we know that density is mass over volume. So we can know the mass of the solid iron by density times by volume. So density is 7,800, and then volume of the sphere is 4 over 3, right? So 4 over 3 pi r cubes. Okay, so 1,800 4 over 3 pi times 0.1 x cube. Okay, so and then you can get the mass of the solid iron is 0.0244 kilogram. So that the mass of the solid iron wrecking ball. Alright, so it's the direct questions. Okay, now you know how to calculate the density of an object. Okay, now how you want to calculate the pressure of an object. Okay, so pressure is defined as the force per unit area. Alright, which is we know that the unit for force is Newton, and then the unit for area is meter square. Okay, so the pressure, the unit for pressure will become Newton meter square, Newton per meter square. Or you can also write the unit for pressure in term of Pascal. Okay, so 1 Pascal is equal to 1 Newton meter square. Alright, so pressure, there is different type of pressure. Okay, so first is atmospheric pressure. Okay, so in the sea level, we can know the value of atmospheric pressure is 1.013 times 10 power of 5 Newton meter square. Or we also can write the atmospheric pressure in terms of 1 bar, which is 1 bar is equal to 1 times 10 power of 5 Newton meter square. Okay, so for gauge pressure is the pressure measured by the instrument called pressure gauge. Okay, so this is by which is means that we measure the pressure by using the pressure gauge. Okay, so how about the absolute pressure? Okay, so the absolute pressure is the total pressure of the system, which is it's a sum of the gauge pressure and also atmospheric pressure. So absolute pressure or total pressure is the sum of the atmospheric pressure plus the gauge pressure. Okay, so in fluid, Okay, we can calculate the pressure in a fluid by you if we know the height of the the height of the fluid. Okay, so in fluid, we can use this equation to calculate the pressure in fluid. Okay, so pressure is also equal to rho g h. What is rho? Rho is the density, and then g is the gravity, the value of gravity, and h is the depth, which is how much depth of the fluid. Alright, so the unit is still the same, which is we can use Pascal. Alright. Okay, so for example, you want to calculate the pressure here. Okay, I call it as a 0.1, and then this one 0.2. Okay, if you want to calculate the pressure at 0.1, so you just only the only pressure that occur here is atmospheric pressure. So at 0.1, actually the pressure exert on that one is equal to P at Tm, or atmospheric pressure. Okay, so at point number 2, the pressure exert here is given by the pressure of atmospheric plus pressure that we can calculate using rho g h. Okay, so P2 is equal to P ATM plus rho g h. Alright. So from the equation pressure is equal to rho g h, we can conclude that if we increase the depth of the fluid, the pressure also will be increased. Okay, so or we increase the density of the object, the pressure also will be increased. Okay, so if you look at the figure, okay, so if you want to know the pressure here, PA, so PA actually is equal to P atmospheric pressure, because it's only atmospheric pressure over there. Okay, but if you want to know the pressure at point B, you need to sum up with the atmospheric pressure and also the rho g h. Alright. Okay, example 8.4. Find the pressure of a point 800 meter below the surface of water. Okay, so you need to sum up atmospheric pressure and the rho GH. Okay, so given the atmospheric pressure is 1.013 times the power of 5 Pascal. Okay, plus rho. Rho is the density of water. H is the depth of the fluid, and G is the value of gravity. Okay, so you will get the pressure at point here is 1.082 times 10 power of 6 per Pascal. Okay, exercise 8.5. So which one you want to look? Okay, for example, question number 3. Okay, calculate the absolute pressure at an ocean of 1000 meter. Assume the density of water is 1024 and the air exerts a pressure of 1.1 kilopascal. Okay, so we have an ocean, and then we need to know the depth is 1000 meter. Okay, the given the density of water, sea water adalah 1024. Okay, and then we have atmospheric pressure here is 101.3 kilopascal. Okay, so the first question is absolute pressure. So absolute pressure we can calculate P ATM plus rho g h. P ATM given 101.3 times 10 power of 3 plus rho 1034, G 9.81, H is 1000, and then you will get 1.03 times 10 power of 7 per Pascal. Okay, the second question is to calculate the gauge pressure at the ocean at 500 meter depth. Okay, so the question asks the gauge pressure. So you only needs to know the gauge pressure. You don't need to calculate the absolute pressure. Okay, so gauge pressure just using the equation rho G H. Just substitute the value of H is 500 meter, and then you will get the pressure over there is 5.02 times 10 power of 6 per Pascal. Alright? Understand? Okay. Now, we will look into the Pascal principle. Okay. So, this one I think you already learned at your secondary school or during your matriculation. Okay. Okay, so we know that in Pascal principle, okay, so for an enclosed vessel, the pressure is transmitted uniformly to every portion of the fluid. Means that the total pressure in everywhere, it must be equal. For example, at point 1, the total pressure here must be equal to the total pressure at point 2. Okay, so we know the pressure, the equation for pressure is force divided by area. Okay, so this one you need to remember. Okay, so the application of the Pascal principle usually we see at the hydraulic press. Okay, where we want to press car when we want to change the tire, something like that. Okay, so we know that in Pascal principle, the total pressure in input piston must be equal to the total pressure at the output piston. Okay, so even here the area is small compared to the second, the output, but the total pressure it must be the same. Okay, so for exercise, the diagram below show a hydraulic jack that used to lift a car which has a mass of 1500 kg. A and B are two pistons with round surface. Round surface is a not square. Okay, if the surface area of B is 130 centimeter square and the force supply to lift the car is 60 Newton, so means that F1, determine the radius of a surface. So you need to know the radius here. Okay, so first you need to know the area here. Okay, given mass of the car is 1500 kilogram. So we know that the pressure at 1 must be the pressure at 2. Okay, pressure at 2 is equal to F2 divided by A. How we want to know the F2? F2 here we can calculate by using mg A2 P1. We need to find the P1 first. Okay, so M1 1500 times 9.81 divide by A2 130 centimeters. So you need to convert 130 1 meter times 100. Okay, square. Okay, so you need to convert here first into the meter square, and then you get the value of the P1. After you get the value of P1, okay, so P1 is equal to F1 divided by A1. Given A1, F1 is equal to 60 Newton, and then A1 you need to find, P1 you already get, and then you can get the A1 is equal to 60 Newton divided by P1. Okay, after you get the value of area, then you can get the value of radius. Since it's a round surface, so area of the round surface, what is the equation of the round surface is equal to 2 pi r square. Okay. So the second question. The output piston of a hydraulic press has a cross-sectional area of 0.2 meters squared. Cross-sectional area 0.2 meters square should be. Alright. So how much pressure on the input piston is required for the press to generate force of 1.56? So we have 2 A1 and A2. So here A2 is equal to 0.2. And then here F2 is equal to 1.5 times 10 power of 6. Okay, so they ask for the input piston. Okay, means that you need to know the pressure here for question A. So P1 is equal to P2 is equal to F2 divided by A2. Okay, so we know the value of F2 1.5 times power of 6 divided by 0.2, and then you will get P1 is equal to 7.5 times 10 power of 6 Pascal. What force is applied to the input piston if it has a diameter 5 cm? Okay, so you know the pressure is equal to F1 divided by A1. Okay, so F is equal to P1 times A1. Okay, so you know the value of pressure and then diameter. So we get the value of force. Okay, so you can try this exercise at home. Okay, so if you have any question, you can ask. Okay, I think that's all for this part. I will continue into the second part later for buoyancy and Archimedes principle. Thank you.